Hello class. So today we're going to talk about compound inequalities. Compound inequalities are inequality statements that have and or an or statement in them. So let me give you some examples. For example, say you had x is greater than 5 and x is less than 10. And so in this case we're talking the solution is something that satisfies both parts of this. So to make it a little bit easier, you could graph each one. Let's say I graph this one. X is greater than 5, so here's 5. It's an open circle, it's everything greater than. And then x is less than 10. Here's 10. It's going to be an open circle and everything less than. And these answers will keep going on this way for that one, and for the blue one it will go everything this way. So we're mostly talking about the things that satisfy both of those, something that's greater than 5 and less than 10. And so if you notice, it's these overlap right here. And so the answer to this, or the way you graph this, or the answer to this question is anything in between these two. Okay, not including 5, not including 10. Alright? So here's another example. X is greater than or equal to -2, so here's -2 right here. It's greater than or equal to, it's a closed circle, it's everything greater than would be all this stuff this direction. And then x is less than 5. So 5 is right here, it's open circle, and everything less than would be this way. So the solution to, or the things that satisfy both of these situations, are all the things that's in between. It's the overlap. It's the things that satisfy this and the things that satisfy this. So say for example 0. 0 is greater than -2 and it's also less than 5. So anything that's in between here would satisfy this, including the number 2 but not including the number 5. Okay, open circle. Alright. Now there's another way you can write this. Say we switch this around and you had -2 is less than or equal to x, which means the same thing as this. Remember, this is eating the bigger number, x being the bigger number in this case. It's still eating the bigger number in this case. So these two ideas mean the same. And this one's already got x like this, but imagine that I just combine these two x's. So this is like saying 2 is less than or equal to x, and x is less than 5. So if I just make this one complete statement, you can write a compound inequality as just one inequality. One big inequality. Okay, so this could be read 2 is less than or equal to x, which is less than 5. Or you could just say x is between -2 and 5, including -2, because it's inclusive here, because this is equals to. Okay, so once again, another way you could read this is x is between -2 and 5. Here's another example. So once again, I could say -4 is less than x, which is less than or equal to 3. Or I could say x is between -4 and 3. So I want all the values, I want to graph all the values that are between -4, not including it, and between, with the upper end being 3. And everything in between, all these numbers will satisfy both of those situations, where x is greater than this and x is less than that. Okay, or -4 is less than x, or x is less than 3. Okay, now or is slightly different. So it could satisfy one or the other. And what tends to happen in or is that, well, let me show you here in the picture. So let's say this one is x is less than 3. So it's all this stuff. X is greater than 2. So it's all this stuff. And as you see, there is no overlap in this case. So with or, it's going to be this one or that one. Okay, so it's nothing in between. It's everything on the outside there. So if you graph this situation, x is less than or equal to -1, you'd be going this way. X is greater than 4, so 4 is open circle and everything this way. Alright, so one or the other situation, not an overlap. There is no overlap for or. Okay, so this is back to, it's kind of like an and statement, but you see that there's something else going on. So this kind of question would say solve for the variable and then graph the solution. Okay, this should give you a hint that there's going to be some kind of overlap because we got this one long compound inequality. So the way we're going to tackle this is you're going to treat it as if it's two separate inequalities. This one plus 3. And then this other one here, x plus 3 is less than or equal to 10. You solve both of these things, so subtract 3. You got x is less than or equal to 7. You solve this one over here. This is supposed to be a plus 3, sorry about that. So you minus 3, minus 3. I don't know why it keeps doing that. And you'll see that this cancels out, and you got x. This is a negative 3 minus 3. Once again, sorry about that. And then your solution here is going to be negative 6. So x is greater than negative 6, or negative 6 is less than x. However you can think about that. If you prefer to switch it around, x is greater than negative 6. So here's negative 6. All the x values that are greater than, so everything this way. And here is x is less than 7 or equal to 7. Close circle. Everything that way. And it's the overlap. And I just realized I shouldn't have made that a closed circle. That should be an open circle. So hopefully you understand that. The overlap is with this part and everything in between here, and also including this one. So this is your actual solution, or how you could graph the answers. Once again, if you wanted to write this as one big inequality, put the x on the right side of this one, the left side of this one. Remember, this has to be the smaller number, and it always has to be a less than or less than or equal to sign. You can't have this be a greater than. So x is 6, negative 6 is less than x, which is less than or equal to 7. Once again, these symbols will always be less than or equal to. Do not have them be greater than or equal to. Okay? X is between negative 6 and positive 7. We always want to have the lower number on this end and the higher number on that end. You could also write your answer like this, as opposed to two separate answers. Hopefully I didn't confuse you with all that drawing on this slide. Here's another situation. Okay, once again, treat it as if it was two separate inequalities to solve. 84 is less than 251 plus x over 4. And then we'll do another separate inequality. This one, 251 plus x all over 4 is less than or equal to 86. Okay, so let's say we solve this one over here. Maybe you recall how to get rid of a fraction. If you times this entire side by 4, that undoes the dividing by 4. But if you times this side by 4, then you got to times this side by 4. Okay, timesing this by 4 will make this 336. Timesing this by 4 once again cancels out dividing by 4. So 251 plus x. Okay, over here we do the same thing. We'll get 336. 251 plus x. And I just realized I made a mistake that this is 4 times, this is going to be 4 times 86 this time. So 4 times 86 equals 344. Sorry about that. So 344. Okay, then you solve for x, so minus 251. Minus 251. So again, I'm not sure why it's doing that. So there's a 3. You cancel, you got 93. Over here you subtract 251. Same deal. So this one's going to be 5. This is going to be 95. Actually, I'm sorry, that's not right. 85. Okay, so 85 is less than x. If you prefer to switch this around, you can say x is greater than 85. So here's your number line, 85, and here's 93. It's going to be all the numbers that are between 85 and 93. This one is going to include, because it's x is less than or equal to. So you graph that one, x is less than or equal to, so all this stuff over here. Then this one is 85 is less than x. So, or you can switch around and think of it as 85. X is greater than 85. non-including everything in between. So this is your answer. If you want to write this thing and this thing as one compound inequality, less than x, which is less than or equal to 93. All right. Hopefully that makes some kind of sense to you. And we're going to do this stuff in class. All right. Hope you learned something. Thanks.